Hi everyone, I'm Andrea Petrocchi and my PhD project deals with stability study of unsteady separated flows. Here, some tips on alternative methods for Buffet onset prediction will be given. Transonic Buffet is defined as self-sustained shock oscillation with flow separation occurring at transonic regime. Despite the extensive research carried out so far, there is still uncertainty around the origin of this mechanism. Moreover, when encountered in flight, it can negatively affect the aircraft landing qualities and cause passenger discomfort. These are the reasons why research on the topic is still ongoing. Buffet conditions can be reached either because of an increase in the angle of attack or Mach number. To estimate the onset of this phenomenon, time marching simulation can be used by repeating them at different conditions. Unfortunately, they can be computationally expensive and even unfeasible when performed on complex geometries. Therefore, here we'll give some hints on how to use alternative methods to cut CPU costs. As first option, runs-based criteria can be used. By looking at the deviation from a linear regime of some quantities, either global or local, at pre-buffer condition, the onset can be estimated for each flight Mach number. Nonetheless, this approach requires a large number of steady computations. To speed up the estimation, the previous criteria can be used together with the adjoint method. It allows for a quick computation of derivatives of some global cost function with respect to the sign variables, that in our case are the flight parameters.
In a recent publication, we combined these tools and came up with a simple algorithm for the onset estimation over a range of Mach numbers. At the boundaries, the criteria are used to find the onset. Moreover, a Buffet indicator must be defined as a function of the Mach number. This can be one of the quantities defined in the previous slides or one of the derivatives with respect to the angle of attack. It will be possible to move from a point to another of the Buffet boundary by knowing the derivatives of the Buffet indicator with respect to the flight parameters given by the adjoint method. Once reached a new Mach number, a check on the current Buffet indicator can be done before moving to a new point. In case the distance between the target and the computed values is high, a correction is applied and the derivatives are recomputed. This way, for each Mach number, the routine requires one steady runs and one adjoint computation, reducing a lot the CPU costs.
The alternative is to use the harmonic balance method instead of time marching simulations. The method allows for the resolution of a periodic flow in the frequency domain through an expansion in Fourier series of the conserved flow variables and residual vectors. Instead of looking at the Fourier coefficients, we use a pseudospectral approach where the solution is split into equispaced instants over a period of oscillation. The method allows for the resolution of the steady flow by solving a steady problem, and the output is the flow solution on a set of points. Results on supercritical alpha at Buffet conditions show the ability of harmonic balance to replicate the results of time marching simulations if a sufficient number of harmonics is used for the Fourier expansion. This can be seen by comparison in terms of aerodynamic loads obtained by the two approaches. The direct comparison of the flow fields obtained at select distance also showed the ability of harmonic balance to accurately describe the shock-wave boundary layer interaction in all the Buffet phases. On top of that, the savings in CPU cost is significant. In a recent publication, harmonic balance computations were embedded in a procedure for Buffet boundary estimation, and this is a comparison between the different methods used. For further details, references were left at the bottom of each slide. Other links you may find interesting are at the bottom page.